Welcome to The Explainer. Today, we're going to become data detectives. Our mission? To find the hidden stories inside those jagged lines of data that, well, are pretty much all around us.
You know, every day we're surrounded by data collected over time. Think stock prices, weather reports, maybe even your own heart rate. And when you plot it on a chart, it often just looks like a chaotic, jagged line. But inside that chaos, there are actually clear patterns, a story that's just waiting to be told. So let's go ahead and start with our first case file.
Our case file begins right here with a puzzle and a plot. We're looking at the number of births per month in New York City, all the way from 1946 to 1959.
At first glance, it's kind of messy, right? Just a jumble of peaks and valleys. This is what we call a time series. Now, the crucial detail is that these data points aren't just random numbers. They are ordered sequentially by time. And because of that, they're often correlated. What happens in February is probably related to what happened back in January. And that connection between the points, that correlation, it's a huge deal. It means we can't just use standard statistical tools that assume every data point is independent. You know, like a series of coin flips. To solve this kind of puzzle, we need a special detective kit.
Okay, our first tool from the kit helps us find the biggest clue in any time series, the long-term trend. This is all about zooming out and just seeing the overall direction of the data.
So what's the long-term story here? Is the data generally going up, down, or is it kind of staying flat? Looking at our New York births data, can you spot it? Despite all those jagged monthly movements, the overall direction from 1946 to 1959 is clearly rising. And that is our first major clue, a long-term upward trend.
But you know, not every story has a rising or falling action. Some plots, well, they stay relatively flat over the long run. Let's contrast our birth data with a different case. So on the left, you've got the upward trend of New York births. But on the right, we see the age of English kings at their death. Notice how it fluctuates, but there's no clear long-term direction. This is what we call a stationary time series. It just stays in the same general zone. Identifying this trend, or the lack of one, is our first major breakthrough.
All right, we found the big picture trend. Now, let's zoom in and hunt for the smaller repeating rhythms that are hiding within it.
If you look closely at the birth data plot again, you'll start to notice a pattern that just repeats itself over and over. Within that long-term upward trend, there's this really distinct annual rhythm. This repeating pattern, within a fixed period, is our second major clue.
We call this seasonality. It's a predictable cycle that happens over a fixed period, like a year. In our New York data, we consistently see a peak in births every summer and a dip every winter. That repeating yearly cycle is the seasonal component of our story.
Okay, so we found a long-term trend and a repeating seasonal rhythm. But what about all those little random jitters that are left over? You know, the ones that don't fit perfectly into these big patterns. Well, even after we account for those big, predictable movements, there's always some irregular, random variation left behind. This leftover component is what statisticians call the residual, random variation, or sometimes just plain noise. It's everything that can't be explained by the trend or the seasonality. As one of our sources puts it, after we decompose the data, what you have left is the random or the error or the noise or the residual. They all mean the same. So the crucial point here is this noise should look truly random, without any hidden patterns. If there's still a pattern in the noise, it means our detective work isn't done just yet.
All right, we have our three key clues: the trend, the seasonality, and the random noise. Now it's time to bring them all together and officially solve the case. And we do this with a really powerful process called decomposition.
Decomposition is exactly what it sounds like. We take our original, chaotic data and we methodically break it down into its three core components. We start with the original series, then we isolate that long-term trend, we extract the seasonal pattern, and finally, what's left behind reveals the random noise. Doing this makes the hidden story perfectly clear. And here it is, our case file summary for the New York births data. The trend component, that shows that steady upward slope, which likely reflects the post-World War II baby boom. The seasonality component reveals that consistent yearly cycle of summer peaks, pointing to a recurring behavioral pattern. And finally, the random component shows the unpredictable day-to-day variations that are left. By separating these, we can analyze each part of the story on its own.
So why does all this matter so much? Because this process of decomposition is used everywhere to make really critical decisions. Economists use it to separate the real growth trend in sales from, say, predictable holiday rushes, and climate scientists absolutely rely on it to distinguish the long-term trend of global warming from natural seasonal weather cycles. It's a fundamental tool for making sense of our world.
So now that you know how to look for these components, the world of data starts to look a little different, doesn't it? A jagged line is no longer just chaos. It's a story with a trend, a rhythm, and a little bit of noise. So the question is, what hidden patterns in your world can you see now?